And we have normal. You know that, right?
Yeah.
Okay. So now they want us to find the smallest value of m for which the variance x is less than 0.6. So which topic do you think this question is testing on? Because it's very important to identify the topic.
Binomial.
Binomial, right? It's binomial. Because firstly, it is talking about discrete random variables. Because it's like number of rate this, right?
Mm-hmm.
Makes sense. And there's a reason why they say let x be the number already selected. So x will follow a binomial distribution of what? N comma p, right? The number of trials. What's the total number of trials?
4.
4. Perfect. And what's the probability?
For red is 5/15 plus n.
Yes. So you have to understand how did this setter set the question. Okay, there's always a reason and a particular style in how this setter set the question. So they got you to do this because they wanted to use it here. Get it?
Yeah.
Yeah. So over here, this 4 here is the n. So from here, they say that for which the variance x is lesser than 0.6. So variance x to be smaller than 0.6. So since we identified this is a binomial distribution, what is the formula for variance of x? Do you know?
Is it like n times p times 1 minus p?
Yes, yes, you got it. N times p times 1 minus. Do you refer to anything or do you just
No.
got it off your off your head?
I remembered this. I don't know why.
Nice. That is correct. Okay, sidetrack a bit. Expectation of x is equals to? If you know variance, you should know expectation.
N times p.
Is what?
It's just n times p.
Correct. Very good. So n times p times 1 minus p will be lesser than 0.6. So from here, you just have to sub it in.
So, okay.
Then from there, you solve for m. Then you can find the smallest value of m.
Okay.
Okay?
Yeah.
Yes. So this question is fine, right?
Yeah.
Yeah. So always understand the setter's intention. Like how I always tell you guys, you know, when you look at the question, understand how this person is trying to set it. How is this person trying to communicate with you?
Okay.
Yeah. Okay. The next one is this. Okay. Hello.
Yep.
Oh, for some reason my screen is stuck. Wait. Okay, let's take a look at this. Okay. They give you fx. Okay, so fx is minus 0.8x squared plus 0.5.
Yeah.
Okay, where x is between 0.5 and minus 0.5. Okay, so
Yep.
Mark uses fx as a model to create a barrel. The region enclosed by the graph f, the x-axis, the graph f is here, I believe. The x-axis and the line x equals to minus, okay, which is this, is rotated 360 about the x-axis. Okay, so I'm not sure if you can see it, but the barrel looks something like that. You know what's a barrel, right?
Yeah.
Yeah. So they say use the model, okay? The model, in this case, they say use fx as a model. So model in this case is referring to fx. Okay, they want you to find a volume. Okay, when you want to find a volume, what's the formula for volume? Do you know?
Pi r. No.
Have I gone through this with
No.
you before? Integration, right?
No.
Yeah, but okay, basically, volume is actually the summation of the area of circle. Okay, imagine a waffle. You know what's a waffle, right? Like,
Yeah.
sorry, my drawing sucks, but or rather roti prata. You know roti prata?
Yeah.
You know what's roti prata, right?
Yeah.
Yeah. So imagine one slice of roti prata stacked on top of another, maybe like 100 roti pratas together. So when you have 100 roti pratas together, it gives you a volume, right? It gives you a cylinder. It gives you a volume of a cylinder. Right? Yeah. So this is what is happening when we are finding volume. Because when you're finding area, when we are finding area, right, what we are actually finding is the area of rectangles. We're actually summing all the area of rectangles to find the area under the graph. Can you see?
Wait, where did you get the rectangle from?
Like, because back then, they didn't have GC. Neither do they know how to integrate. Okay. So let's say if it's a curve like that. So people in the past, like way back into the past, what they do is they use area of rectangle because it is easy to use to find the area of rectangle. It is easy. So they will use like very tiny strip of rectangles. Okay, they will find all the area of these small strip of rectangles. You know?
Mm-hmm.
Yeah, they will find the area of all these rectangles and they sum all of them up together to find the area under the curve.
Yeah.
Of course, it will not be accurate. Why? Because as you can see, there are gaps. Can you see?
Yeah.
Yeah, there are gaps. So what happened is this. Because of the gaps, that's why they decided to reduce the width of the rectangle. So imagine the width of the rectangle is reduced to, imagine the rectangle becomes like a string, as thin as a string. So if we have infinite number of string, it will close up all these gaps, isn't it? If the rectangle is as thin as a string.
Yeah.
Yeah. So, Okay, I think I'm going into the concept really, but I don't think you need to know this. But basically, how they find area in the past is to use areas of rectangles. So now when we find volume, what is happening is that this one rectangle is going to turn 360 degrees around the it's going to turn 360 degrees around the x-axis. Okay, this one rectangle is going to fill up 360 degrees about the x-axis, which gives it like the area of a circle.
Yeah.
Right? So actually this symbol, this integration symbol, it is not an F. It is actually a S. It means summation.
Okay.
Yeah, so we're actually summing the area of circles, pi r square.
Oh, okay, yeah.
Yeah. So I hope this helps you to remember the formula, pi r square. But what is this r? This r is actually your y. Okay. So that's
But
why.
what's the y here? Like, which y value do you use?
Y is your fx, right? Because we always state that, oh, y is equals to fx.
Oh, okay, yeah.
Yeah.
Okay.
So you just need to know this. So it's actually the sum of the area of rectangles. Okay. So area of rectangles, sum of area of circles, sorry. So sum of area of circles, just remember you are summing like a lot of roti pratas together. Like really a lot of roti pratas together. You know? Yeah. So from here, we know what's the fx. The fx is minus 0.8 x squared plus 0.5.
Oh, so you just put that into the calculator and then
Is this paper 2?
yeah. But then
Yeah.
like for like for like the range, was it just 0.5
Yeah,
to
you have to
minus
integrate
0.5?
from negative 0.5 to 0.5.
But you put 0.5 on top, right?
Yeah. Sorry, 0. That's all you got to do.
But what about the pi
Sorry.
r squared?
Oh, sorry, my bad. Made a terrible mistake. Pi. Then you have to square this.
Okay.
Yeah, but from here you can use the GDC.
Yeah.
Yeah, then you should get a numerical answer.
Yeah.
Yeah.
And then for the next part.
The empty barrel is being filled with water. The volume V of the water in the barrel after t minutes is given by this. Okay, so it says V is equals to 0.8 1 minus E to the power of, I can't really see, man. Is it
I think
minus
it's
0.1?
let me check. Yeah, minus 0.1 t.
Okay. How long will it take? So this is the volume after t minutes. How long will it take for the barrel to be half full?
It would just be the volume over half.
So we will need to find, because, okay, so same thing again. Why did they ask you to find this? It's because this is for you to know the full volume.
Yeah. Wait, let me just
Yes.
put it in the calculator.
Yes, from here you can times half, you get the half volume, then you can put it here. Once you put it here, you want to solve for the t, you use
Oh, so you just sketched a graph.
All good?
0.5. Oh my god, no. I just cancel everything. How do you do a square? How do you square the... Oh, I have to put another bracket in. I got like 0.6, the volume.
Okay. The full volume?
Yeah. The volume of the barrel.
Do you square it? Do you do this? Do you multiply by pi as well?
Yeah.
So you did this whole thing.
Yeah.
0.6.
Yeah.
Seems a little small, but I mean, it's still positive. Then from there, you have to divide by 3. Because this is definitely correct. This is definitely correct.
Wait, why do you divide it by 3?
Divide by 2. Sorry, divide by 2.
Oh, okay. And then you get like 0.3, but
Yeah.
then
after that, you plot the graph of this. Then you find the intersection between this and a horizontal line, 0.3.
wait, so which intersect do I use?
I'm not too sure how the graph looks like, but definitely it has to be positive.
Wait, is this the X value or the Y value?
It's the X value.
Oh yeah, okay. I can't find the intersect. There's no like two curves.
You plot the horizontal line.
Oh.
This is one graph,
Oh.
this is another graph.
Oh. Wait, why is that so? I thought that's a value. Like that's equals to.
Yeah, because you want this to be equals to 0.3, right?
Yeah.
Yeah. So on this graph, you want to find out for which t value, which is the x value, for which the y value is 0.3. You understand what I'm trying to say?
But okay, so the volume, because they want to find out like how long it would take for it to be half full. So half full is 0.3.
Mm-hmm. This is the equation for volume. So when you plot this graph, this will show you for every value of t, how will the volume, which is the y value, changes. So you want to find the x value, which is the t value, for which the v is 0.3.
Ah, okay.
Yeah.
Okay. It's like 4.7.
Yeah, because I don't have the calculator with me, but as long as it's positive, it's fine.
Okay.
This is the right method of doing it. Even if your answer is wrong, you still get the method mark. So the least amount of marks you should, minimally you should get 2 from here and 2 from here, if your concept is correct.
Okay.
Okay?
Yeah.
Next. Okay. So firstly, identify topic. What's the topic?
Statistics.
What?
Like. Oh wait, no, probability. Sorry.
Probability, yes. But which part of probability? Just now I mentioned it can be discrete.
Normal.
It can be, yes, correct, normal. So we are very sure that this question is on normal distribution, right? So the weights of the newborn babies in Australia are normally distributed. So we will let W be equals to the weight of newborn babies. This is what I will be writing now during the exam. Okay, it is normal. They are normally distributed with mean blah 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 blah. So this is step 1. Step 2, step 1 always define W. Step 2 define the distribution. So W will follow the normal distribution, 3.41, and standard deviation 0.57 square. Because you should know that the notation is this: mu, comma, sigma square. You know that, right?
Yeah.
I mean, even if you don't know that, it's fine. We'll be going through. Okay, so a newborn baby has a low birth weight. Okay, low birth weight if it weighs less than W kg. Okay. So they say that given 5.3%, okay, they are giving you the probability here, yeah? So this will end up on the right-hand side of the equation. Have a low birth weight, okay? So step 3, define the problem. Probability of W lesser than the small w, okay? Because they say if it has a low birth weight, if it weighs less than w, right? Correct? So if the
I
big,
don't understand. Like, oh wait, okay, so okay, zero. Okay, yeah, I get it. Sorry.
yeah, if
Yeah,
the big
continue.
W is smaller than, I mean, the weight of the newborn babies is smaller than W, okay, then this is equals to 0.053.
Wait. Oh. How is it like 5.3%? So like 0.053 is equals to big when small w is bigger than big W. I don't understand
No,
that.
big W, as in this W here represents what? The weight of the newborn babies.
Yeah.
The probability that the weight of the newborn babies is lesser than W is 5.3%. I'm just
So a
translating.
newborn baby. Ah, okay.
All you need to do in statistics, right, is to translate English statements into mathematical statements. That's all I gotta
Okay.
do. Yeah. So this is my go-to method when doing statistics question. Step 1, I always define the random variable. Then I define the distribution. Lastly, I'll have to interpret the question and define the problem.
Okay.
All good?
Yeah.
Okay. So from here, what is given to you is the probability. What we want to find is the limit. Is the boundary here, right? So this is when you need to use inverse norm. Okay.
Wait, what are you trying to find here?
You're supposed to find W.
But okay, so but how did you know that it's inverse? Oh, because it's like
Because look, let's say right now W follows normal distribution 3.41, 0.57 square. Okay. So and then they tell you that okay, find the probability that W is greater than 5, for instance. So from here you'll be using the normal CDF, right? Correct. From here you'll be using your calculator and use normal CDF, and then with the upper bound being like infinite, like very big number,
yeah.
99999, with the lower bound will be 5, right? Yeah, so from here you're going to use normal CDF to find what is this probability. But now what we want to find is this number over here. So we are trying to reverse the process. That's why we are using inverse norm.
Okay.
Okay, we are trying to reverse, because usually when we use normal CDF, we are trying to find the probability. But now the probability is given to us. We are going backwards right now. That's why we are using inverse norm.
Yeah.
Okay. So when required to find the limit, which is the bound, the upper bound and lower bound, use inverse norm.
How do I get the inverse norm? I can't find it on calculator.
This is a problem. I do not have the calculator right now. If I'm not wrong, is there a stats option?
Yeah, I went there.
Okay.
Then they don't have it. It's linreg. Oh, okay, I found it. You have to do like second distribution. So inverse norm. Wait, so for normal CDF and normal PDF, is it the same?
Different. You never ever use normal PDF.
You always use CDF, right?
Yes. You don't use, it's not in our syllabus. Don't use that, okay?
Yeah. So inverse norm.
Yeah.
The area is 0. What's the area? 0.053.
Yeah.
And then oh wait, do I do 0.57? Just 0.57. Oh yeah. How do you know whether it's the left or the right?
Good question. So your calculator prompts you the left or right tail, right?
Yeah.
Yeah. Look at the arrow. This is my trick. Look at the arrow. Is it pointing to the left or pointing to the right?
Wait, what arrow? Oh,
This inequality, right? Can you see that it is actually an arrow?
yeah.
Is it pointing to the left or to the right?
Left.
Exactly.
Will it
Left.
always work?
Always work. Yes, always. So let
But
me.
what if they ask you to draw the thing?
Okay, yeah, that I was just about to draw the thing. So let me explain to you why is this always true. Okay. So what this statement is trying to say, okay, the probability that the weight of the newborn babies is lesser than W is equal to 0.53. What we know from the distribution here is that the mean is 3.41. Right?
Yeah.
Okay, so now they are saying that when the weight of the newborn babies must be, if the weight of newborn baby is lesser than W, the probability is 0.053. It's only 5.3%, right? So it's either that the W is here or the W is here, right?
Wait, why? I don't understand that. Sorry.
Okay, they say that the weight of the newborn is lesser than W. If do you know what is this curve?
It's
You
like
know,
the distribution.
yes, it's the distribution, okay? So you must understand that the area under the graph, like let's say, for instance, so you have to understand that this graph is always symmetrical about the mean, 3.41. So probability of X greater than 3.41, which is here, this area here, this area is actually the probability.
Wait, no, but if it's greater than 3.41,
So this is equals to 0.5, which is 50%.
wait, what?
Okay,
When
why am I doing this? I'm just trying to explain to you that the area under the curve is the probability.
oh, okay, yeah.
Okay, you have to know that. Now they are saying that the probability that the weight of the newborn, okay, follow my cursor, yeah. The probability that the weight of the newborn is lesser than this W, okay. The probability when the probability of the weight of newborn lesser than W is
Wait, are you
equal to
moving anything?
0.53.
Hello.
Hello?
Yeah.
Yeah, it's equals to 0.53. It's only 5.3%. Right? When the weight of the newborn is lesser than W. So this probability is a very small probability, right?
So that means it has to be smaller than 3.41.
Yeah, right? It has to be smaller than 3.41. It has to be somewhere here.
So 5.3.
So it has to be this should
Are
be
you sorry, are you drawing anything? Okay, yeah.
so this is the area. This is the probability of W lesser than of weight. Okay, see, it's very confusing. They intentionally use yes. They intentionally use the same letter. Okay, so the probability of the weight of the newborn to be lesser than this W over here.
Can I not change it?
I mean, right now, as while we are discussing, I can use another variable. Maybe I use A.
Wait, but then why is the okay, so basically it's just saying that if anything that's way less than the small w is 5.3.
Yeah, correct. Okay, imagine okay, what I'm trying to ask you here is that do you think the A is here or the A is here? Given that the probability to the left is 0.053, which is 5.3.
No, like I would think it's on the left because it's like small, like it goes from small to
Exactly,
big.
because we want it to be, we want the weight of the newborn to be smaller than this A, right? Instead of using W, we use A. The W is really
Smaller than 3.14.
yeah, it has to be smaller than 3.14. Because if it's here, this will take up a very, very, very large probability.
Yeah.
Which will not make sense. Right? And that's why it is on the left tail. Can you see?
Yeah.
Yeah. So do you really have to draw it? I mean, in such a scenario, you don't really have to draw. My trick is to use the inequality. Look at where the arrow is pointing to. If it's pointing to the left, it's left tail. If it's pointing to the right, it's right tail.
Yeah.
Yeah.
Okay.
Okay.
Yeah.
So a newborn baby has a low birth weight. So they already said this. Find the probability that the baby weighs at least 2.15 kg.
So you have to move it to 2.15.
So you need to know what is this W first.
Yeah. I found it. It's 2.48.
2.48.
2.49. 2.49.
2.49. Sorry, I need the 5 SF.
Oh, 2.4886.
Okay. Why do I say this is important? Because we will need this answer in part B. So that's why you always express in 5SF, then you round off to 3SF.
Yeah.
Roger? Okay.
Yeah.
So from here in part B, what is happening is that they say that okay, this newborn baby has a low birth weight, okay? So since it has a low birth weight, means that the weight is smaller than 2.4886. Agree?
The weight is yeah.
Yes. The newborn baby will weigh lesser than 2.4886. Okay? But now they say
Yeah.
that find the probability that the baby weighs at least 2.15 kg.
So 2.15 and above.
Yes. So now we want to find a probability that the W is more than
2.15.
2.15 but smaller than
Smaller
2.4.
than 8. Oh, okay.
Yeah, because we cannot just find this. We cannot find W to be greater than 2.15. Because if it's greater than 2.15, it may exceed 2.4886. Once it exceeds here, this point here, once it exceeds this point here, it will not be under the low birth weight category.
Yeah.
That's why this serves as a restriction.
Mm-hmm.
Do you understand?
Yeah.
I hope everything is clear.
Yeah, it is. So wait, but what do you use for this? I forgot. Like which?
Normal CDF.
Why is it still normal CDF?
Because now you're finding probability. If you're finding probability, you always use normal CDF. If
So
you're
you
finding
never.
limits, you will use inverse norm.
Okay, but what about binomial CDF PDF? Is that just binomial distribution?
Exactly. That's why the first thing that I asked was,
Okay.
remember, right? That's why the identifying a topic is very important. That's why I mentioned this before. Creation is the highest level of learning,
Oh my god.
right? Creation is the highest level of learning. When you're able to create something, right? When you're able to innovate something, right? I tell you, you're godlike. That's why, right? We have to learn. We have to understand, right? How did this setter, right, create this question? Once you can get into his head or her head, right, you figure this person out. Once it's not about figuring the question out, it's about figuring the person out, the person behind this question.
Yeah.
Yeah, it's usually the case. Next time when you get into sales, you meet a client, if you understand the needs of your client, right, you'll be able to convince your client to buy this.
What do you think creation is the what?
Creation is the highest level of learning.
Where do you get these quotes from?
It's true. It's true. It's like humor, right? Humor is the highest level of intelligence. I mean, if sorry, I forgot what was the quote already. Something about humor. 1 minute.
Oh my god. Wait, hello?
Hello? Yeah.
Oh yes, yeah.
I can't find it. But basically, right, you know when you talk to kids, right, like babies, or don't have to be babies, like toddlers.
Mm-hmm.
Yeah. If they understand your joke, right? It means that this baby is going to be very, very smart.
What?
because humor indicates a very understanding humor. If someone is able to understand humor or create humor, right, it means that this person is highly intelligent.
Then I think I'm highly intelligent because I always create humor.
I think you're not bad.
Bruh, no.
Intelligent, not in a way of like academic intelligence, is like it's not that kind of intelligence.
Mm-hmm.
Yeah. It doesn't mean that you are funny means you are able to score well for IB. It's not that kind of thing.
Yep.
But yeah, creation is the highest level of learning. It's true. If you are able to create a normal distribution question, it means that you have fully mastered this topic.
Wow. It's
Right?
a bit far.
Like, I mean, you can use some reference. I tell you, the best way to revise, right? But very few people get to that level. Very, very few. The best way to revise is not to do question, but to create question. Like, you go and find some reference.
Your mic is like,
Sorry,
can't hear you.
can you hear me?
Hello? Okay, yeah, I can hear now.
Yeah, I think the best way to revise, right, is to go and find some normal distribution. Or let's say we are on top. Let's say we are on the topic of normal distribution. So go and find some reference questions, and from there try to create a question on normal distribution, and then do up the solution and let your friends try it.
Okay.
That's the best way, because you understand, oh, this was actually what went through the setter's mind when he was trying to set this question. These are the different perspective of looking at how to set a question.
Okay.
Yeah. Okay, I think we are done with this.
Yeah.
Let's move on, okay?
Yeah. To differentiation.
Yes. And we are moving on to differentiation. Give me 1 minute, I'll have a sip of water first.
Okay.
Yo.
Yeah.
Okay. So differentiation, yeah? How do we differentiate? There are three ways. How to chain rule? Do you know how?
Are you asking me? Oh.
Let's say for instance we have okay, we use this, okay? The first one, x to the power of 5. So now let's say y is equals to x to the power of 5. Okay, then if you want to
X
do
to the
dy dx,
5x to the 4 to 4.
Very good. Okay, so let's say if y is equals to 5x to the power of 6 plus 2x to the power of 4, 7. Can you show me?
do, yeah, 5x. Okay, so you do, oops, did I draw? Okay. Do you do this? Do you do the inside?
Yes.
Oh no.
No. Leave it. Leave
Yeah.
it.
Oh. Wait, the pen. You do.
So you have to multiply by the differential on the outside.
Either you do 30x plus.
Correct. Okay?
Yeah.
So with that said, can you erase for me?
Yeah.
So with that said, I think you should have no problems doing every question here. Right? Because all these are just chain rule.
Yeah, I understand this one.
Yeah. As for this rule and this rule, here you just have to expand it, then differentiate.
Wait, can we just go through one question?
Which one?
Like the question 10.
Okay. Okay, so first and foremost, what I will do is I'm going to transform all these into index form. From here, I'm going to multiply in. Then when I multiply in, what I will get is half plus 1 over 3 is 5 over 6.
Yeah.
This will be 3 over 4. Yeah. Then from here, I will do my dy dx, which will get me
And then oh, okay, so it's just like that.
yes, ma'am.
Okay. Okay.
Okay, let's move on. How to product and or quotient rule? Do you know how? So let's say, for instance, we can use, let's say, okay, let's say if I want to differentiate this. Do you know how?
You do. I forgot the equation.
Okay, I'm going to teach you right here. To do product rule, you will have two terms multiplied together. Okay, you will have
Yeah.
two terms, one term and a second term. So whichever term that comes first, you differentiate it. Okay? Whichever term that comes first, you differentiate it first. So in this case, I'm going to get 4x. Right? From here.
Yeah.
You're going to differentiate one at a time, which means that after differentiating the first term, you're going to hold the second term.
Okay.
Plus. Okay? Take note, it's a plus.
Wait, I just have a question. Why is it d over dx?
Because I'm differentiating this thing.
Why isn't it dy dx?
I mean, usually you'll be like y is equals to 2x squared minus 3 minus 5 plus 3x to the power of 5. Then after we have this y is equals to this, then we can do like dy dx. Provided we have already defined y to be this, then we can write dy dx. Because over here I did not define what is y, that's why I will put d dx of this.
Okay.
Trying to differentiate this. This means differentiate this. Because this means I'm trying to differentiate y.
Okay.
Get it?
Yeah.
Okay, back to this. So we saw this thing coming first, so we differentiate to x squared minus 3 and we get 4x. So we are going to hold the second term, which is minus 5 plus 3x to the power of 5. Okay, always remember it's always a plus. It's very important, it's always a plus. And then the next step will be to hold the first term.
And then you differentiate the second one.
Exactly. Multiply by 15x to the power of 4.
4.
And there you go.
Do you not do divide by something?
No, that is under quotient rule. So this whole chunk here is product.
Okay.
Next, quotient rule. So let's say I'm going to d dx. For instance, let me take an example. Let's say 2x squared minus 3 over 1 minus 3x. Okay, let's say I'm going to differentiate this. So whichever term that comes first at the top, I'm going to differentiate it. So what I'm going to get is 4x, right?
Yeah.
Yeah. Then same thing, I'm going to hold the bottom term, 1 minus 3x. Okay? But over here,
Yeah.
it's a bit different. We are going to minus. Okay? We're going to minus. We're going to hold the first term, the top term. Then we differentiate what is at the bottom.
So 3 minus 3.
Then we're going to divide. Okay, divide by what? Divide by the denominator square.
Okay.
Okay?
Yeah. Wow, you have really good drawing skills.
You are the first and only person who has said that to me.
Yeah.
Wait. Sorry. Were you being sarcastic?
Yeah, of course.
Damn, shit.
What is that? What is that thing?
I thought that was genuine.
No. Oh my
I
god.
feel like shit right now. You just destroyed my life
Destroy your dreams.
of being an artist. It is abstract art, okay?
No, it looks like I don't know. It looks like a claw.
No, it's okay. It's like the fingers, you know.
But to be honest, actually, it looks like a swan.
Swan?
Yeah.
From where?
It looks like half a phoenix.
See, I told you, actually, I was trying to draw a phoenix.
Yeah, sure. Of course
For a
you
moment,
were.
I thought you were making a genuine comment. Serious.
Oh,
I felt so good for a while.
for like 1 second.
Yeah, for like 1 second. Then after that, my brain just registered from my history that no, she can't be serious.
Yeah.
Of all people, she will be the one complimenting me. It's not possible.
It wouldn't be me.
Yeah. Okay, so product and question rule is very simple, right? Practice time. Okay.
Okay, so the first one is quotient. The second one is quotient. The first one is quotient. The third one is quotient. The fifth one is quotient. The seventh one is a product.
Okay, how about you show
Wait.
me product rule first?
Okay, so 7. You hold the first term. No, you differentiate the first term. Wait, when you differentiate e to the x, you get what do you get?
Again, differentiate what? EX, is it?
Yeah,
You get EX.
doesn't change, right?
Doesn't change.
Then you hold the second term, which is 5x cubed plus 4, and then you plus, and then you hold the first term, which is ex, and then you times x squared plus 4. Then you get you just do when you times it, you can't times
That's
this,
good
right?
enough. That's good enough.
Oh, you have to like
Yeah. I just wanted to see the
no, but
step.
when you times ex to the 5x cubed, what do you get?
Okay, look, actually over here what I will do is I'll just take out EX. So I'm left with 5x cubed plus 4 plus 15x squared plus 4, which is equals to EX 5x cubed plus 15x squared plus 8.
So you leave it like that. Okay. And then
Okay,
do the
show me a quotient rule.
so I'll do 3. When you differentiate ln x is 1, is it?
Actually, we are going to touch on that later, but that doesn't matter. We'll just do it now. Differentiate ln x will give you 1 over x. If you differentiate ln 2x, for instance, or rather 2x cubed,
Oh, so it's 1 over
okay,
2x cubed.
you'll get 1 over 2x cubed times 6x squared. You have to differentiate this.
Oh, so you do 1 over whatever, and then you times it by the differentiated form.
Correct. So basically, right, if you want to put it, you want to formulate it, it will look something like that. Fx, okay, it will be equals to f prime x over fx. F prime x means differentiate.
Wait, but why do you divide it by? I thought it's one. I thought you get whatever you get, like 1 over. You get 1 over fx. What do you get f prime x?
F prime x is this, right?
Oh yeah. It's just times. Oh, so yeah, sorry. It's times, yeah. Okay. Okay.
Okay, go.
Get is no, you x disappear. 1 over x divided by 1. So you get like x basically. No, wait. Okay. We can do x over. Can you just put 1?
Yep. It is what? X over x is 1.
Yeah, so you do this. It's correct, right?
It is correct.
You leave it like that.
Yes.
Okay, perfect.
Okay, so actually my next slide was
And then question two is product rule as well.
yes.
Then when is it chain rule again?
Actually it really depends because it's really up to you. Do you really want to expand this? If you can expand this, you can do chain rule.
No, I don't.
Yeah, exactly. So it depends from case to case, because if I were to see something like that, I will do chain. Right?
Like something super easy.
Yeah, something easy you do. Actually, chain rule is inside product rule and quotient rule.
And yeah.
Yeah, I mean, because chain rule is what exactly is chain rule? Is to bring the power down, like is to bring the power down, and then minusing the original power by 1.
Yeah.
Yeah, that is what chain rule is about. So that chain rule is inside the whole of differentiation. It forms the basis of differentiation.
Yeah.
Okay, we will come back to this later. Okay, I wanted to teach you this, but can you help me to erase it? Yeah. I wanted to teach you this, but we already did. So, I mean, just do a quick recap. Let's see if I exponential x squared. How do I differentiate this? I will still get back the same thing. Multiply by 2x. Okay?
Wait, what? No. So you get e.
You will get back the same thing, right? Then you have to multiply by the differential.
You multiply by no, but you only differentiated the top part. The power.
Yeah, correct. You have to multiply by the differential of
The
this.
power. The
Yes.
differential of the power. Okay.
Yeah. So which
Oh, yeah,
also
yeah.
means, let's say if I have this exponential 2x, what we'll get is e to the power of 2x times 2.
What? Oh, because it's 2x now. Okay, yeah. Okay.
Understand? Very easy.
Yeah.
If I have ln 4x to the power of 5 plus 2, what I will get is 4x to the power of 5 plus 2 and 20x to the power of 4.
Wait, what about the long? What about the ln? Where does the ln go?
The what?
The ln.
Gone.
Why?
It's just like
Because
that. You don't need to know the
previously,
proof.
previously when you did like ln, ln. Wait. When you did like ln, yeah, and that slide. No, not this one. Oh, it's gone.
I wrote something like that. Ln
You did,
fx, right? Was this the one?
yeah.
Then I'll get f prime x over fx.
So you
There's no ln.
differentiate.
There's no more ln. The ln is gone.
Oh yeah, because I was thinking about like if you do if you do differentiate ln x, you get 1 over x.
Yeah, correct. Differential ln x is 1 over x.
Yeah. Okay.
It's 1 over x, not ln over x. No.
Yeah. Yeah.
Okay?
Yeah.
Very simple. So, with that said, you can maybe show me 6. Oh shit.
6 is
Can you see? So I can expand it.
just a bit bigger. Yeah. Bro. That's too big. Okay.
Is it better?
Yeah. Let me just put it here.
Yeah. Just let me know whenever you need me to expand it. It's free.
Okay. Yet
What do you guys eat over there?
school food
Like,
would taste like shit. It's so bad.
what do you eat again?
It tastes like shit.
Not acid. Okay, I know. But what do you eat again? Like you cook or what?
Like menu is different every day.
Oh, you catered food.
Yeah, they have to like they give you food.
Oh, it's like a meal plan kind of thing
Yeah.
from school
Yeah. But every Friday is fish and chips.
every Friday.
Yeah.
So is it good?
I don't eat it. I eat the salad. I eat salad more.
What? No wonder you slim down so much.
Wow, thanks.
Why? You really did slim down, you know? Like
Thanks.
you're like very slim right now.
No.
Wow. Wait a minute. Which means they cater your breakfast and lunch and dinner.
Yeah.
All 3 meals.
Yeah.
But you can't be eating that all the time, right? I mean, you will be heading out to eat sometimes.
Yeah, like sometimes I order food. Like you can only order on the weekends.
You can only order on the weekends.
Yeah.
So on Monday to
But then
Friday,
you can't order food like on Friday. I'm sorry, on Friday, Saturday, and Sunday you can order food. But But then on weekdays you have to eat the food, or you can, like, if you have time, like, you can go out after school to eat. But then I don't have the time. Like, most of the time I don't have the time. They
Why
wouldn't
why
let
will
you
you
have
not
the
have the
time.
time? Like, I mean, after
I
school you can just
After school I'm in the library, or I'm in the classroom
for what?
to do my work, or I have to go for gym.
Gym?
Like, basically before I was in, like, high school, like when I
Okay.
was in lower school, every day after school there is something for you to do. Like, you have to either be volunteering, like doing some service, or you have to do sport. You have to do sport like 4 times a week, and then you have to do or you have to, like, be in, like, like the seas, like army, marines, or air force. You have to choose one of them to be in, and you have to be in it for like once a week.
Or the uniform groups.
Yeah.
Okay. But now you're in year 5 and 6. You still have to do that now?
I have to go for sport like twice a week. Like
Like,
today, like
uh-huh.
basically today after my lesson review, I'm gonna go walk the hills.
You're going to what?
I'm gonna walk the hills, like the
Walk the
hills.
hills.
Like, like, okay, basically my school was on a hill,
Okay.
and then there are like hills for you to walk. So instead of doing sport, I'm gonna go walk the hills.
Like, it is a sport.
Yeah, it's like because you can consider that a sport, because I'm in, like, high school. I can choose whatever I want to do, or I can go to the gym,
But who is
or
there to mark? Who is there to take your attendance?
I have to sign out of the house.
You have to what?
So, like, I have to sign out of the house.
What house?
My
Like,
house, like the house. Like, basically we're in different houses. Like, all of us are in different houses. I'm in, like there's like house 1, house 2, house 3. I'm in, like,
okay.
I'm in Leslie house. Like, my house is a name. I don't know why. But yeah.
Okay.
And then yeah, you walk there.
Wow, this is very mind blowing. Okay. So you can just go to a you can just go in you can just go to the gym, then that's
Yeah, but
counted as one sport.
yeah.
But you can just not do anything. But do you do anything in the gym?
No, yeah, I go running in the gym.
No wonder you slim down.
No, but I have to do it. No, but in, like, sixth form, which is like year 5 and 6, you don't really have to, like, do anything. Like, they close one eye. Okay, in year 5 you have to do shit. Like, they actually, like, care if you didn't do it, because basically last year I skipped quite a few gym slots and I got into, like, trouble for it.
Oh, okay.
But then this year they don't give a shit. Like, they just want you to study. So I'm
Oh.
always in like the econ department doing something.
So right now you are at home or are you
Yeah, I'm in the house. I'm in my room.
okay? Wow. The culture is so different over there.
No, basically when you come to like boarding school, it's like going to jail. Nah, okay, no, it's not jail. It's not that bad. Like, I don't really mind it, but it's like your life is basically planned out for you, which is perfect. So my parents don't have to give a shit.
Mm.
And then
But it's so sad that you have catered meals for every single meal from Monday to Thursday.
Monday to Sunday.
Huh? It's from Monday to Sunday.
Yeah, they have like a meal plan.
Then what happens if you don't eat it?
Basically on weekdays you have to eat the lunch. Like, breakfast and dinner you don't have to eat, but the lunch you have to eat.
But they will still serve it, right?
Yeah, they still serve it. If you don't eat it, they're just gonna throw it away. Basically, there's a lot of food wastage. Like, half of the food is, like, wasted because no one eats it.
Oh my god. Okay.
Yeah, after coming to school, I actually waste a lot of food because I don't like I just wasted that because it's bad. It tastes really bad.
Is it like what? Western, Chinese?
Oh, they try to do like some Chinese food, but it tastes like shit. They serve like buns, and they serve like sweet and sour chicken or noodles,
Mm.
and then most times like Western food. Like, yeah.
Oh, this is interesting. When I grow up, right, I want to go to a boarding school.
When you grow up.
Not yet, man. Not yet.
What?
Not yet. I'm still growing.
Wow. Wait, when you differentiate 5e to the x,
Mhm.
you just do it's just 5e to the x, right?
Yes.
Because when you differentiate
Okay,
the
firstly, you
x,
don't have to you don't have to care about the constant. Okay? You don't have to care about the constant. The constant will always remain. What you're concerned about is this.
and the power.
And a power, yes. So like for instance, like when I differentiate 5x squared, I don't really care about the 5. The 5 remains as it is. What happens is I'm going to bring the 2 down. Yeah, because the 5 remains as it is. You get me?
So 5, and then you get 5 times
Yeah.
what?
Yeah, 5 times 2x because I'm going to differentiate the 2x. I'm sorry, I differentiate the x squared. Let's say if I have 5x squared.
Oh yeah. Okay.
Yeah. So you don't really touch the
It's the
constants.
same
That's what I'm
concept.
trying to say. You don't really touch the constant.
Okay. Then 4 ln e to the x is you get um 1 over. Wait, what? How do you? I'm so confused. How do you do for? Whenever there's like a ln x, I'm confused. Hello.
Yeah. Sorry.
When you do like 4 ln e to the x.
Okay. So this is something that you need to know. Ln e x is equals to x.
Oh my god.
Basically, ln e. Okay, look, because why ln e x equals to x ln e, right? Because you know you can bring this down, logarithm. You know that?
Mhm.
Yeah. So and what is ln e? Ln e is, if you use your calculator, what is ln e?
Wait. I think it's 1. No. Wait. Ln e. I can't find e. Oh, okay. 1. Yeah.
That's why ln e x will be equals to x.
Okay.
Hmm.
So this equals to 1. Ln e equals to 1. Okay. And then so I get so this is x for x. Yeah. Is this correct?
Yes. No.
What?
No. You will get 4x. Here, this is actually 4x. So when you differentiate 4x, you get 4.
Oh my god, you still have to differentiate 4 to 4.
No, okay. Look, over here, this is actually 5ex. I mean fx, fx. fx is actually equals to 5ex plus 4x. So you're supposed to differentiate this.
y equals to
Yes, y is
5.
equals to this.
Ah,
Buddha bless you.
okay. For
You understand what I'm trying to say?
yeah,
fx is equals to 5ex plus 4x. From here, then you start to differentiate. But
to dy dx.
yes,
Okay, but y equals to 5ex plus 4. Okay, yeah, I get it.
you get it, huh?
Yeah.
Okay, show me 4.
4. Oh, this is brutal. So you do like e to the 2 ln 4x. Is it like that?
Okay, wait. Can you see here? Can you see what I wrote here? What can you understand from this?
Oh, so whatever ln whatever is, but it's 2 ln 4x.
E ln smiley face is equals to smiley face. So when you have E ln 4x squared,
Equals to 4x squared.
yes.
Oh my god, why do I have to remember so many equations? Like,
No, actually, there's no need to memorize for the one earlier. When you have ln e to the power of x, it's logarithmic laws. You are supposed to bring the power down.
yeah, no, but then I'm confused when it's like, so like, but then what about ln x? ln x?
You mean for right now, this one?
Let's say if it's like ln 4x, you get 1 over 4x. No?
Yeah,
But then why did you say it was like,
times 4.
okay. So it's 4 over 4x, which is,
So right now over here, what I'm trying to tell you is that E ln 4x squared is equals to 4x squared. This is like
okay.
uh, a trick to simplify this thing, so you don't have to go through the hassle.
Oh, wait, no. Yeah.
Yes. Okay, then
What about question 3?
yeah, I wanted to ask you to show me that. Can you show me that? It's the same thing. It's the same thing.
Question 3. Y equals to oh my god. You get 1 over e to the 3x times. Is it like that?
No. Just now I told you,
Oh my
right?
god.
Ln e 3x to the power of 4. What should you do? This thing you bring down, right? So you get 3x
Oh.
to the power of 4 ln e. And what is ln e?
1.
1. So you're left with 3x to the power of 4.
Okay. Let me try it. Mm. It's like that. Hello.
Yeah, I'm looking. Yes.
Okay.
Okay, 1 minute. All right. Okay, these are the compound. Can you erase it for me?
Yeah.
I think maybe we don't really have to go through this because I think you should be able to cope.
Really?
Okay, how about you try
Question 12. No, question 5.
12 is just tedious. There's nothing wrong with 12. 12 is just okay. You know what technique to
Question.
use for question 12?
Yeah. The
What?
product rule.
Exactly. So it's just tedious. There's no need to do this.
No, actually, I need to do question 5.
Yes.
I hate anything with E and learn. It's just horrible.
Can you see?
Yeah, I can. It's really big. Okay. Wait, I'm gonna get some water. So
So
okay, so can I bring this to like y equals to, no wait, let me, is it 3 ln x?
remember just now what did I say? E ln
Oh yeah, e ln that thing equals to that thing.
E ln
Smiley face is smiley face. Oh my god. Seriously.
do you get the joke?
Yeah, of course I do.
You're very smart though. Because some of my
Thanks.
friends, right? No, I'm not being sarcastic, serious. Some of my friends, right? They don't even know who the shit did who they don't even know who this guy is, you know.
Uncultured.
They don't even know who this guy is. I'm like, what? You don't know who is this guy? Like then I went on to ask them, do you use PayPal? They're like, yeah. Then they're like, do you know the self-driving car Tesla? They were like, yeah. I'm like, what? And you don't know this guy? Incredible. This guy is God sent, you know.
When you do x and you do it to the power of 1/5, right?
Okay. Very good. I see that you're trying to simplify it first.
And then
So what should you do from here? I will bring up the denominator.
how do you inverse it? Like when you do like, how do you bring the 4?
Like that.
Yeah, you get like 4 and what?
Do you understand?
Because you do so you do -4, because 4 x to the 4 to the 1/5, you get x to the 4/5, and then when you inverse it, you put the minus sign, and then you bring the 4 down. Is that right?
What do you mean? Okay. So what happened was, because originally it was like that, right? X4
Yeah.
1/5. So I got the 1/5 in, so it becomes 4 x 4/5.
Yeah.
Okay. So I wanted to bring this thing up. So it
So you
becomes
get
4x to the power of minus 4/5.
okay.
Then from here, you can do your chain rule.
chain rule. Oh yeah. You just dy dx, 3x squared, and then
Yeah.
minus 16 over 5 x to the, I don't know. Yeah, minus something. Minus 1, minus 4 over 5. 1, yeah. Okay.
Okay.
Yeah.
Remember this, huh?
Yeah.
I hope you won't forget this. Elon Musk equals Mars. Just remember that.
Yeah, that one I remember.
Nice. Took me a while to think of that. I don't think we have time to go to tangent and normal. So maybe
Should we do another?
you show me one last question.
Yeah.
Like this. And this. Okay?
Okay. Let me just, I'll do 6 first. Shit. Is it 3 over x?
Hmm.
No. Okay, perfect. And then question 10. Oh. E to the e to the 4. Oh my god, I still can't do e to the 4x. Are you serious? Is that a dog?
It's a freaking cat. It says perfect.
It looks like a dog.
Oh my god.
It looks like a dog and tiger.
I'm dying.
Oh my god, I'm dying. I can't do e to the 4x.
How to do that? 4x cubed.
What's the first step?
What's the first step? When you differentiate e to the power of anything, you just copy and paste, right? It's the same thing.
Oh.
I'll let you carry
Oh
on.
yeah. Wait, it's just that. Yeah, when you do Is it just this?
Then you have to do something.
Oh, you times it by 12x squared. Okay. I hope I got it. I need to rewatch this video.
Did you watch Parasite?
Yeah, oh my god, it was
Oh
so
my god,
good.
it's so good.
It's so good.
It's so
Like
good.
but I found it's so funny though, the movie.
It was damn intense. I was like, my heart was in my mouth.
It's something so simple, but it's something so
Yeah, the director is the director.
yeah, he's so
It's-
good, like
Yeah, it's the director. It's not really the plot, it's the director, you know.
yeah, the way he did it, no, but the plot as well. Like it's something so simple. But then the
Yeah.
way he like executed it, it's so like I don't know. But I found it really sad because like I don't know, like how the rich man was super mean about like that basically is about like how like you know how these poor people they their problem is like not finding a place to stay, but then these rich people their problem is like camping and just like freaking raining. That's their biggest problem.
Yes, and it
It was
and it is a real world problem. This movie truly depicts what is actually going on in the world right now.
that's kind of true.
Yeah, this is the truth. That's why this movie got a lot of awards. It's not just about the very awesome cinematography, but also it's a true depiction of what is going on in the world right now.
Yeah.
Yeah, like the rich despises the poor, and the poor is just struggling to survive, you know, and in turn, as a result, the poor tries to take advantage of the rich, but ends up doing it the illegal way.
Yeah.
And that's why the poor will always get poorer.
Bruh.
Yeah. So it's a whole vicious cycle.
Yeah.
Yeah, I would really like want to rewatch this again. Yeah, it's like
Really
every
good.
poor problem, right? Every poor person has their issue. It's like even the former servant, the maid, the housemaid, like she hid her husband in the dungeon.
Yeah.
Yeah. So it's like what I think another takeaway is that no matter whether you're rich or poor, you have your own issues.
Yeah.
Yeah. Like the wife.